All right, so let's discuss some of the issues with A. I think most of us memorized a little bit what we were writing and didn't look at the question. So I asked you to write a corresponding vector equation. So this is basically taking you back to EV1 and saying, okay, I know how to write a linear combination. That is a C1 times my first vector, C2 times my second vector. That's how I write a linear combination, right? Oops. Because that's what we're looking at, this linear combination. And it needs to be a vector equation, so I need an equal sign. And it's nice for linear combination because we have a result vector, so we could just go ahead and write that. The first thing we had to do was convert all of these matrices into vectors. So we're in R4. Multiple right ways to do this, but the one that corresponds to the augmented matrix that you're given below maps this to the first element, then the second, then the third, then the fourth, right? So like you were looking for your linear transformation. I'm not going to write it out. But yeah, so this is what we were looking at. Boom. Now, again, a lot of folks wrote this and then didn't do anything else. Some wrote out the statement about linear combination, which does not include a vector equation. We need a statement about its solutions, right? So its solutions, this has at least one solution. Additional linear dependence is not a big deal. In fact, that's what we end up having in our answer in B, right? We have a free variable. The last question here is it did say the set of 2 by 2 matrices is isomorphic to what Euclidean space? So M2, is isomorphic to R4. And that's because we have these 4 different elements that we're mapping, right? If we actually rewrote this basis, the basis for M22 is 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, and 0, 0, 0, 1. And if we wanted to show that sort of isomorphism, that linear transformation, that's a bijection between the two, we could easily come up with some rule that moves from M22 to our R4, maybe just as simple as T of an ABCD matrix is equal to A, B, C, D. So I did write out that linear transformation. But what I was looking for here, at the very least, in order to get a 2 out of 2, was that vector equation and then has at least one solution, or is consistent, right? Second piece here is, okay, now we have a reduced row echelon form. The whole point of this is we can take things that are a little bit tougher to work with, matrices, polynomials, other things. If we're isomorphic to a Euclidean vector space, we can just represent things with vectors, and we can use all of our cool tricks. So here we know the easiest thing is to zero out this free variable, and then we can say that we have 4 times 0, -1, -1, 1, minus 4 times 1, 0, 0, 1, plus 1 times 1, 4, 5, -5 is going to give us that result we were looking for, -3, 8, 9, -13. No need to check your work unless you just want to verify, but even looking at this last element, -4, -4, minus 5 is a -13. And then part C, it says use this to answer the original question. The whole this was, is this one matrix a linear combination of the other matrices? So we're just going to go ahead and convert these things back to our matrices to show that this result works whether we're in matrices or in our column vectors because of that isomorphism. That's the power of all of this. So that was the last step of this problem. It's all you had to do. Like I said, I think the part now that's keeping students from the 2 out of 2 is part A. Read carefully, make sure you're answering what I'm asking for, as opposed to just memorizing a previous version and regurgitating.